Alright, Mastering Solidworks, Chapter 23, Animating with the Motion Manager. Motion Manager is the interface that enables you to create animation showing the motion of parts and assemblage based on a time frame. Animation can be arranged with a simple rotating part, complex moving machinery involving motion constrained by assembly mates for motion driven by motors, springs, gravity, contact. Render animation photo view 360 shows the SolidWorks display mode including real view. Collectively, the results of any motion capabilities in SolidWorks are called motion studies. Some of the capabilities are more focused on analysis, called simulation, while others are involved simple in animation, but can create movie output. In this chapter, you will learn to use Motion Manager, create rotating, exploding view animations, animate view changes in Motion Manager, use key points, work with basic motion, animate exploded views. SolidWorks has three primary and two ancillary methods of creating motion and assemblies. Animation. This creates simple motion driving the animation wizard, keyframes, mates, and motors. Basic motors include motors, springs, frictions, and standard mates. SolidWorks motion analysis. This includes basic motion as well as force and dampers, and will calculate loads, velocity, acceleration. This is covered in because it is not part of SolidWorks standard. It's available only with SolidWorks Premium, SolidWorks Simulation Professional. There are two ancillary methods of capturing movies. Walk through the summary of pre-existing tools prepared where simplified interface for architectural type. Walk through animations. Record screen. Record simple view, rotation, dynamic assembly, model motion. Exploded view used to animate the steps of exploded views. Make controller. The mate controller is the interface controlling mates toward the goal of creating animation without first creating configurations. Familiarize yourself with the Motion Manager. To get usable results from these tools, you need to be comfortable within the limits of technology that SolidWorks provides. Your success with the tools depends heavily on having realistic expectations of their capabilities. Understanding terminology. Here's an overview of the terminology with the conjunction with the motion in SolidWorks. Motion Manager. Motion Management is the interface gives access to animation, basic motion, SolidWorks, motion tools, signal interface, controls all the tools. Animation. Animation uses the keyframe method. The software interpolates between positions established by mates, freehand drag, position, Viva the triad, or XYZ values. Does not confuse animation with dynamic assembly motion, which is simply dragging parts in an assembly with a cursor to create motion. Basic motions use motors, springs, cavities, and gravity, so on. It does not use keyframes. It includes physical dynamic features, which deals with calculation motion due to collisions. SolidWorks motion. If you needed detail input output, including graph functions, SolidWorks motion is best choice. Options available in SolidWorks standard level of software, so is not covered here in detail. If you need a function that only allowed another type of the motion study, you need to change the motion. You should type, then drop down, select the type box, upper left corner of the Motion Manager. Default option, animation, other two available options, basic motion and motion analysis. Motion analysis is available only if you have SolidWorks motion turned on and if the tools add in dialog box. That's available only if you have SolidWorks Premium or SolidWorks Simulation Professional. You can see these study type boxes and interfaces shown in Figure 23.1. Alright, over there on the right it shows a camera video recorder and then a camera with a square that's been grayed out. Another method you can create capture screen motion is movie file using record video tool. Video screen capture record video tools appears on tool button screen capture toolbar. You can use the record button to record whatever happens in the graphics window from using the rollback bar to the dynamic assembly motion dragging parts with the cursor. Note, the videos accompanying the book were recorded using third-party screen capture and video editing software called Camtasia Text by TechSmith. Alright, your major elements of Motion Manager. You have your filters, your study type, your Motion Manager toolbar, your animation wizard, your Motion Manager design tree, motion study tab, change bar, key point, time bar, timeline area. Driving and animation. You can animate the following: distance mate, angle mates, part appearance, include display mode, shaded wireframe, and so on, part transparency, part visibility, part position, view, zoom, camera position properties. When you animate colors and appearances, simple colors can fade from one to another, but appearances of the texture do not fade. It will simply snap to the next texture appropriate time. For example, if you can fade red to blue, but you cannot fade marble to fabric, this is also true with fading transparencies and animation that is rendered using Photo View 360. You cannot animate the following: changing part dimensions, changing Photo 360 materials configurations. Although you can animate changing part dimensions directly, some creativity with the animate within context change driven by changing mates. You will see the example of creating a part with flexible later in this chapter. You use these items to drive an animation. Key points: animation mates, animation motion, basic motion, SolidWorks motion. Motors, animation, basic motion, SolidWorks motion. Gravity, basic motion, SolidWorks motion. Spring, sub, basic motion, SolidWorks motion. Contact, basic motion, SolidWorks motion. Friction, basic motion, SolidWorks motion. Force, SolidWorks motion. So force and dampers are only SolidWorks motion, and that also includes contact. Your animation or your key points, mates, and motors, and gravity, springs, and friction are both basic motion, and SolidWorks motion only. These types of motion are available with kinematic, mates, and motors, animation, basic motion, SolidWorks motion, dynamic, physically based, basic motion, SolidWorks motion, free motion based only on key points, animation. When you think of physics SolidWorks, you may need to adjust some of your expectations. Some of the tools don't follow real physics concepts rigorously. For example, the motor applied in part of the assembly creates constant velocity instantly without regarding an error. Friction has only single component rather than static and kinetic, which exists in real engineering problems. You can stimulate a static state friction, which forces an equation, but isn't available in function of friction. Playing animation is often useful to plan animation that must be involved with a few moves on the screen. You can do this a couple of different ways. The easiest way to write out a list of moves or a position you want to display with approximate time of each action or position. Another way, the storyboard technique employed with the professional video graphs. In this method, you can see a series of images to represent a state of animations at specific points in time. Use static screen captures in SolidWorks and hand sketches to do this, depending on the complexity of geometry and animation. In general, even the simple animation, the better your plan, the better final product will be. The animation tools SolidWorks tend to perform much better when you follow a clean workflow without lots of major editing. Simply, you could probably say about almost any process, but the animation tools seem particularly sensitive to editing. Identifying elements of Motion Manager. The parts interface that you will use at most of the key points of the design tree with a time bar. Filters help you select the view limited set of items and tabs at the bottom and enables you to set up alternative studies. Playback speed enables you to change the rate and playback either the view of the long animation more quickly, see motion in one area more detail. Timeline zoom enables you to rescale the time interval on the timeline. Figure 23.1 identifies major elements of Motion Manager. Alright, using display options. When recording an animation to a movie file, series or still images, or a series of still images, you can choose from several types of display output. First and easiest type, the default SolidWorks display without real view. This is the most appropriate, fast, and technical presentation. You may want to use this demonstrate function particular mechanism. Simply rotate around a model to demonstrate with a model of 3D rather than flat image or E-drawing. You can also turn a real view record animation. If you do this, you should have appropriate appearances for individual parts. Real view appearances enable you to use the reflective textured materials on the part. Highest quality images come through Photo View 360 rendering. Using Photo View 360 takes much more time than the other options because the individual frame must be rendered just like the normal Photo 360 rendering. Photo 360 is beyond the scope of this book because it's not added in. It's not an add-in on SolidWorks Standard. SolidWorks Visual is another SolidWorks rendering product. Visualize is separate and standalone rendering and is not included in the scope of the book. Alright, using Motion Manager Interface. You can access Motion Manager Interface left-hand corner graphics window, model 3D views, animation tabs, enable one, Animation 1 tab enables you to toggle the interface on and off. The Model tab shows the normal SolidWorks interface. 3D View tabs enables you to capture 3D views of 3D PDF, step W/PMI, and or E-drawings. You can add the tabs to multiple motion studies. You can see if the interface you may need to turn on Motion Manager. To do this, right-click on the toolbar, select Motion Manager from the list of toolbars. Motion study properties with the Motion Manager shown in Figure 23.2 enables you to establish accuracy frame rate of the display of the gear symbol on the Motion Manager toolbar. So over here. Formatting output. The Motion Manager enables you to create animation SolidWorks outputs as AVI files or series of bitmaps or TGA still images. You can use it as a default open GL SolidWorks Real View Display Conjunction Photo View 360 create more realistic rendering animations. You can control pixel size, frame rate, rendering, recorded animation to help control finish size, more quality amount of the time it takes to record animation. You can rotate fly through single parts and assemblies. You can also make assembly mechanisms move through animation mates, driving them, motors, manually position parts in spaces. So here's the motion study properties. Animation frames per second, basic motion frames per second, geometry accuracy, low, 3D contract resolution, low to high, general contact 3D, geometry accuracy, and low to high 3D contact resolution. It also comes with general options using setting the defaults. New motion studies show all the motion analyst messages. One of the beautiful things about SolidWorks animations is if you can save them in an e-drawing file, you can send e-drawings to a non-SolidWorks user for review because the file is format is small. You can easily send animations over the internet. Alright, using Animation Wizard. You can use Animation Wizard to create simple animation. Animation Wizard accommodates two types of animation. First is whether the part in assembly is simply rotated on the screen, the camera revolves around the part or assembly. Second, use existing exploded view from the assembly. You can combine, reorder, reverse, copy, or move both types of animation sequence with the larger animation. Alright, rotating animation, your Animation Wizard. Simply rotating animation, you can create a rotating animation. First click Animation tab 1, bottom left hand corner, graphics window. This opens Motion Manager interface. Remember that you can turn Motion Manager on and off. In the list of toolbars, check Tools, Customize Views, Toolbars. Right click any tool across the setting of the Motion Manager. Click Animation Wizard icon toolbar, top of the Motion Manager, Figure 23.3, show the dialog box. Where you can choose options include rotate, model, explode, collapse, import motion from basic motion, import motion from motion analysis. An example, the option of the grayed out except for the rotate model. The model that is loaded does not have to explode, view, basic motion, or SolidWorks motion data. So the first page of Animation Wizard select is will create automatic motion. Select the animation you want to create, rotation, explode, collapse, import motion, basic motion, import motion analysis, scroller access study, make controller, and you can delete all existing paths, and then you can go through back and next and cancel and help. After you select the appropriate type of the animation, click next, select an axis for the rotation, number the rotation directions. Important thing to note here is that X and Y axes do not refer to axes of the part. They refer to axes of the screen. Rotating about the X axis is holding down the right arrow of the keyboard. Sample animation appears up left corner. Animation Wizard shows that you can expect it. It changes direction. It can change the option in Figure 23.4. So once again, the important thing to note here is that X and Y Z axis do not refer to axes of the part. They refer to axes of the screen. You can do the select axis rotation X, Y, and Z. Number rotation clockwise, counterclockwise. Final step of creating rotation animation is determine how long the animation will last and what point of overall animation should start. 23.5 shows the Animation Wizard page where you can set these options. Looping is controlled only during playback. Actual animation is beginning and end. So if you want to play a finished movie that is smooth looping, you make sure that the start and end point of the animation are the same. After clicking Finish, Fit Motion Manager will populate a timeline key points of the orientation camera view. Instead of rotating the part, software will rotate the view. It seems systematically different, but when you start working with moving parts and assemblies and changing view, the difference becomes important. Notice that heavy backline with diamonds in a row of orientation camera views. Figure 23.6. The expanded diamond is key point representation. View angle line between diameter diamond indicates motion manager interpole the view between key points, making view transition smoothly. You will learn how to create key points later in this chapter. So here's all the diamonds in the 10 seconds. You have your video recording, play, reset, play, spring, cam, something else. Alright, it shows over here the play from start. To play the animation, click the play from start play button with the motion manager tool. Notice that you can run an animation wizard. Notice that also that you can run an animation wizard multiple times, creating various sequences in single animation. You can control the start time duration, which add the time. You can also add key points, even mirror the path. Creating an exploded view animation. Samples assembly with the animation folder of the download materials is robot assembly, solid assembly. As it's saved with exploded view, you can use the assembly, create your own. If you use the file first create a new motion study for practice, do that and right click the animation 1 tab on the bottom, select create new motion study. Use the animation wizard, create animated exploded collapsed. Exploded and collapsed. First start with an assembly with exploded view. Activate the animation wizard. Remember, exploded views are kept under configuration. Configuration manager 23.3 show the first page animation wizard where you select the animation type. Select the explode option. Click next. 23.7 show the second page explode animation. Skip the second step, which is used to rotate animations. Second page is exploded. It will begin with the type of the animation. Create, rotate, metal, explode, collapse. If you add exploded animation to the end of the rotate animation, resulting animation does both rotate the exploded each of the sequence. Later, you will learn how to copy and reverse these key points to explode to make collapsible, how to adjust key points to make parts move faster and slower and simultaneously. You can also edit animation created by the explode collapse in the same way you would either edit, rotate, and animation created by the wizard. Both have multiple parts moving at different times that can edit sequence certain parts of the same time. Marquee, selecting your control, selecting group key points, moving along the timeline, animating assembly. Here's an example using Animation Wizard to first rotate a model and explode, collapse it, and was with a simple editing. If you want to follow along with the example, open yoke, link, solid assembly, the download materials, chapter 23. Note that this assembly already has a complete animation. You need to create a second motion study when you want to try to make your own animation of this assembly. Creating an explode. First step of creating animation is to have an exploded place and starting animation. To do this, you switch to the configuration manager. Activation configuration would create an explode, creating a new configuration. Each configuration can hold multiple explodes. In this example, the new configuration is called example. Right-click name of the part of the configuration manager and selected add a configuration. Figure 23.8 shows the configuration being added. We've now went to the new configuration assembly. We went to add configuration to the top of the yoke assembly. To add a new explode, right-click the new configuration name, select new explode view shown in 23.9, add exploding bring property manager shown in 23.10. In this property manager, you create individual exploded steps. Now we'll move to the explode, adding a new explode as steps, and then direction, distance 1, rotation, angle, degree, rotate each of the origin, configuration, new exploded view. Detailed exploded sample, steps of sample. Without reviewing the materials, explode chapter 13, building efficient assemblies in detail, general warfare, creating individual explosive steps as follows. Select a part, select a regular step. Translate, rotate, radial step, use triad to move part, you must have set the exploded direction for parts not aligned with the sub-assembly axes. Repeat, steps 1 and 3 show each of the explode you want to add. Each of these 6 explode steps, step 1, different explode steps. Explode nut and bottom opposite side radial, select fat face of the nut and cylindrical face of the bolt, tug orange arrow to pull them opposite sides, explode with the strap straight up. Explode head and bushing straight down together. Explode bushing to one side must be established in direction. Explode thyroid down to half distance head bushing explode. Now that you've exploded the is complete, make sure the assembly is collapsed state. Right-click the exploded view under configuration name before displaying the motion manager interface. Change the assembly to the property orientation. Put a spacebar display view orientation dialog box. Select animation 1 view, then choose view orientation dialog box. Click the right and click on the animation 1 tab below bottom left-hand corner Solidworks window. Display the motion manager interface. C. Create new motion study. This gives you a fresh start with a new animation timeline. Figure 2311 shows how to create a new motion study. Now we've left clicked it and we've creating a new motion study. Alright, and it shows the camera with a wizard one. Next is animation wizard icon, motion manager toolbar. Select an animation type would appear, shown in figure 2330. Select rotate model option, click next. Next window selection Y axis option, click next to remember. In this X axis means X axis of the screen, not the model. If there was an X axis of the model, assembly would be similarly spin in place. Putting rotate into animation timeline. Animation control options window. Set the rotation last 3 seconds. Start time 0. Change start settings later to get some practice making. Edit timeline key points. When clicking finish, you get the result shown in figure 2313. Using animation wizard, add key points to animation timeline. Or when making an animation, it's nice to have a gap between the start of the movie and the motion part of the viewer, some time to adjust when he is seeing on the screen. Of course, you're making a movie that you want to use a continuous loop gap might interrupt the motion. You can also insert a gap between the end of the motion and the end of the movie when you make a gap seem more natural. In case you want to add a gap a second, 1/2 at the beginning of this animation, do this, drag a selection window around the heavy black line, black key points, and the orientation and camera view row, then drag the right in slightly less than 1 second. Adding the explode to the animation. You can add the explode animation, do the following steps. Start the animation wizard again, but this time select the explode option, click next. Animation control option window, set the duration again to 3 seconds with the start time at 6.25 seconds. Click finish, then the result is shown in figure 2313. Bringing the explode steps into motion manager, and it shows these different steps. Collapsing the exploded assembly. Now that you will add the collapse but the time without running the wizard. To accomplish this, follow these steps. Drag rectangle around the key points created by the explode. Control drag the first copied step that lands about 1/2 second after the last original key point. With the block key point selected, right click one of the copied key points, select reverse path. The copy exploded now becomes a collapse. Changing other than explode, dragging key points pair of key points, for example bushing of 3 key points in this path, you delete the mid key point and shorten its motion to match the head. Animating and zoom. The next step of the zoom is looped area of the strap. To do this, you first make sure the view is the same as the last change made to the orientation. In this cap at the last key point of the rotation manager, click drag same time that the collapse finishes. The move time bar forward a couple seconds, zoom in so you can see the fork. Then loop section of strap, right click the time bar and row of orientation and select place key as shown in figure 2314. Alright, we've moved into the left and we've chosen flexible area of the strap. Has move time bar view orientation and camera view, and then something key and select all in animation wizard. There are other ways to place view orientation key with enabling the orientation camera views. Enable the orientation motion manager records every view change you make, so it's cleaner and safer if you just use the right menu bar place key method instead of enabling the orientation. Making a part look flexible. Click calculate button motion manager toolbar. Notice that when your strap moves up, the part actually shortens. The part would also twist later with the animation, which would change the angle of one of the parts. In general, Solidworks cannot animate flexible parts, but you can use some of the tricks to make appear with the flexible. You can animate part dimension changes, but you can animate mate dimension changes. You can do this using context relation, driving the mates and change the distance of the angle made. Therefore, the appearance of flexibility comes only through animating parts within context relation. May be well thought out and out of features. Animating through in-context relation is not available in basic motion. animating a changing mate. Next item that this movie will animate with angle 1 mate that expands mates folder in feature manager. You find those that has two folders. One folder is model mates and the other folder is for mates driving the animation. The only mate the animation mates folder is angle 1. Start by copy the initial key point of the angle 1 for 0 seconds slightly after the view change that you just made. Next, move the time bar 1 more second past copied key point. You can do this precisely by right-clicking the time bar, selecting Move Time Bar, then typing the type and the time in which you want to move it. Double-click with the angle 1 mate changes value from 45 to 180. Making the angle mate change from 45 to 180 back to 45, then 0, then 45 again with about only 1/2 second each change. Remember, you use copied key points to make multiple 45-degree values. Finish the animation, return to the original view. Do this to copy the first key point orientation, then the last key point about 10 and a quarter seconds. Figure 23:15 shows final result. The examples for the demonstration overall workflow while the rest of the chapter over detailed discussion functions that are available. Animating the view. Section reintroduces some of the view animation items saw earlier in this chapter. This tool involved the changing point of the view with the animation is recorded with this first part chapter most offered a practical overview of the animation workflow. This section gives you a more knowledgeable individual tools changing controlling the view. You now understand how the tool combines to make animation. Now you just need to know what tools are available and how they work. View animation is an important and reusable function. For example, you save animation where only things are animated on view change within assembly, then you can put any part of the assembly that you want in pre-created animation in your photo 3 views. 360 settings are established except materials and appearances for individual parts. You can even create a rendered animation very quickly by reusing existing data. Great example is when you show an assembly spinning it on its axis like a turntable instead of the axis of the screen is shown by the animation wizard. In this case, you can record a camera following a path focused on a particular point. This is a great animation to set up with this template. You can reuse the quick and easy animation boilerplate. This technique is covered later in this chapter. You can animate the view change of the motion manager as following ways. Orientation camera views must be enabled. Use key points, move time bars, rotate model. Use key points, move time bars, rotate model. Right click, select place key. Use animation wizard to rotate a model. Use any of the above techniques with a camera. Attaching a camera to the part that moves. Attaching a camera to the path that uses animation or walkthrough. Using a screen capture to record the screen. Driving the view with key points. A key point is a point with a timeline where the tells Solidworks what state something will be in at a specified time. For example, in 9 seconds, view will be at front view, and that was represented by a diamond along with a timeline that contains the information. You can use the key points to animate the symbol of motion view and even properties such as color, transparency, mate values. We've already done some work with key points in this chapter. Alright, it shows the telescope using orientating camera view features. It's an important fact about using view and camera key features. Orientation and camera view features motion manager is locked by default. This means you cannot change the view in the animation by accident. To unlock it, right-click on the orientation and camera views entry and deselect the disable view key creation option. If you don't understand why the setting is turned off turned off by default, try working with it turned on for a while as you're learning the software. You may find unless you are extraordinarily well organized, you will make unwanted changes to views because you are unconsciously rotating the view to see if it's better or forgetting the changes being recorded. This is a very common mistake among users creating an animation. Best practice, best way to handle orientation camera views feature is to keep it locked and use the right menu mouse button, replace keys when you want. Disabling playback of view keys. When you can playback the assembly and animation, disable the view changes. To do this, right click the orientation camera views items motion manager, select disable playback of view keys from the menu. Where often dealing with an assembly motion, it helps to see the assembly with a particular point of view. You can't do that with the animations always changing the view. Remember to deselect the setting before recording the animation to a file. Alright, introduction to time bar. The time bar is a vertical gray line timeline area that denotes the current time that you are editing the animation. For the figure 23, 1. Identify the major parts of the motion manager interface. Make a change to any element in the key. It can be animated that the changes apply by the time denoted by the time bar. To make the key point driving animation, workflow usually involves moving the time bar, making a set of changes, moving the time bar, making another set of changes, and so on. To try this out of the assembly. Open a robot assembly in the robot arm folder from the download materials. You can follow along with the existing motion study. Create a new one. Experiment on your own. Start making sure the time bar is set to 0 all the way to the left. Then position the view in the start animation. In this case, display view orientation dialog. Press the space bar. Double click the view name 1. Because the orientation in the camera views item is displayed, disabled, the view change is not recorded. In order to record it, right-click the key point on the right orientation key at camera views and replace key is shown in figure 23:16. This replaces existing key with a new view orientation. You can edit key point time, view orientation, camera view, replace key, cut, copy, delete, paste, select all, suppress keys, interpolation model. The view should remain static for a brief time animation starts. It might be too confusing to start animation immediately viewing change. Create the pause. This pause, copy the first key point of the 0-second mark and 1-second mark. It's easy as it sounds. Click key point in the same row, orientation camera wizard. Then control drag it to the right to select 1-second mark. And let's cause the first second of the view to be static. Creating key points. Next, move the time bar with the 3-second mark. Display the view orientation dialog box again. Activate view 2. Right click on the orientation row. Intersect 3-second column. Select place key to make a new key point. View orientation black bar between the 1-second key point and the 3-second key point indicates that the animation will interpolate the view orientation between two defined points. Motion manager now looks like figure 23:17. Timeline is the timeline, the 2-second mark. Remember, the view orientation dialog box stores both orientation and zoom factors, so when you use view 2, it zoomed in a different state. Therefore, when you view changes from 1 to 2, it may rotate the zoom in or out slightly. If you may measure rotation more precisely, it may be a good idea to use arrow keys rather than something like a 3D mouse. Zooming in free view manipulation. Next step is zoomed it into the gripper simultaneously to view slightly to give the better view. Better changing the view, that would be nicely to have another pause to give the viewer a chance to see what was there. To create the pause, click the last key point in the orientation camera view row. Control drag from the 5-second mark, then move. Time bar to the 7-second mark. Remember the workflow copying particular key is and select the control drag, not just control drag. If you control drag without making an initial selection, you may be copying other key points that were also selected at that time. The select operation saves you 2 functions. To deselect anything else, to select the 1 key point that interests you. After you have the time bar, move to the 7-second mark of the view orientation. Press the space bar, move to the view 3. After doing the zoom into the grippers using whatever method you use, the zoom, shift, Z, middle mouse button, scroll, zoom to area, zoom to selection, zoom in and out, 3D mouse. After you have them made both changes, add the key point to orientation change bar, same way you've done it previously. Rotate and zoom will happen at the same time. Idea is to get a good partial side view of the grippers, such as the view shown in figure 23:18, playing the animation, see what you have created. Using interpolation modes. When playing an animation, it may appear somewhat jerky. Motion Manager interpolates between key points, changing either view or part position. Default interpolation mode is linear. This means it changes between points at constant speed. With this creates the jerkiness between motion starts and stops abruptly. To remedy, the Motion Manager offers several interpolation modes. Right-click one of the key points that you've created and select interpolation mode. At the bottom of the list that appears, another menu will fly out, as shown in figure 23:19. So we've now picked interpolation, linear snap, ease in, ease out, ease in, and ease out. The icons of the mode significantly How the motion increases, decreases key points. In any case, if the curves make smoother motions than lines, ease in, ease out creates the smoothest motion. Ease in works best at the beginning of the change. Ease out works best at the end of the change. Snap causes an abrupt change in position from one place to the part will move immediately to another location for the next key point. Linear option causes the part to move at a constant velocity from one part point to another. Default mode is linear, so if you want to change all 4 key points, you must go through the selection of 4 times, right? There's an easier way. You can box select all 4 key points, right click any of the selected key points, change them all to ease in and ease out mode. Now play the animation again. Notice how much smoother the views changes are. Alright, correcting mistakes. When you start with the motion manager, you probably make mistakes. Don't feel bad. This happens to even seasoned veteran. The difference between you and experienced users is that you know how to deal with a mistake without panicking. The motion manager does you the favor of recording all your mistakes in the form of adding key points to change line for either part of the position view orientation. One way to troubleshoot these types of mistakes is to drag timeline through the key points, identify the key points that needed to be edited or removed. To edit the key point, you can use the option of the right mouse button menu, and such as replace key, edit key time, select different view orientation, and so on. Move the key point, just click and press delete. If you're making an animation that covers a long period of time, say more than 30 seconds, a key point may be closer and difficult to distinguish from one another. You can use view tools, lower right corner, timeline area, zoom timeline in and out. Zoom in and makes key points appear farther away from one another, enabling you to select one of them might be right on top of another. Alright, the camera, in blue, using paths to control the camera. Main camera controls, you need animations as a target by selection, position by selection, set roll by selection, addition, field of view settings. These settings are available if you right click and click on the right mouse button on the camera. In the scene's light and camera's pane of the display manager, select edit camera. Alright, recalling the walkthrough feature. Walkthrough and standalone feature functionality is borrowed for the motion manager for the animation camera as long animation on cameras along a path. Walkthrough the feature is somewhat simplified and intended with large structures where you can go in and around the object. Remember that Chapter 22, working with large scale designs, we use a very large dump truck with a staircase and an observation platform. Rotate the model using the path. Main weakness of the rotating animation wizard is that it rotates about the screen axis, which appears to make it wobble on the screen. It typically is not what users have in mind when they ask to rotate the model. Most users envision a turntable sort of rotation where the model rotates about its own axis. Checking the rotation rotate about the part axis isn't easy. It's probably out to be, but after understanding the process, you can simplify it. This example involves making a camera revolve around the axis of the part, regardless of the orientation part. Show how to drive the camera along the path. The exercise start and simple, but gradually becomes more complex. Best way to spin a view around a part axis is to make a loop path on the plane perpendicular to the axis. The plane should be, in most cases, slightly elevated from the base model. Probably should be circular, at least smooth, closed loop spline. Starting with a robot, assembly download material robot itself, assembly move the top of the view, open 3D sketch. When doing prep work like this, it's better to work using a model instead of motion manager. This prevents you from creating unnecessary key points with animationable items. In 3D sketch from the top of the view, draw a 4-point closed loop spine as shown in the figure 2320 with using the 3D sketch so you can change the path to the non-linear. So you can change the path to non-planar if you decide. The path does not have to be perfectly circular. In fact, it might be better if it gets closer to the assembly on one side, making it rather kidney-shaped. You can use the circle, ellipse, or closed loop spline for the path. Next, press shift down arrow, rotate view 90 degrees, drag the entire spline up a little bit, view a tweak a couple little spline points. The spline goes higher and lower. This will give more interesting result than just a straight turntable rotation animation. Shows creating a camera, and it's been a little bit twerked. To greatly simplify the task, you create an offset plane sketch an ellipse circle on the plane rather than using 3D spline. 3D spline is intended to give the most control and flexibility The camera will be attached to the spline. You might also want to have the target point for the camera to follow that goes around the path. You can play with the sketch point inside of the joint between the tower arm ports. If it is somebody even a part of origin is convenient location, you can also use the place to point a camera. After this path exit the sketch and insert the new camera. You can insert the camera by switching the display manager multicolored bulb next to the feature manager and configuration manager tabs. Then switch to the third icon under the top tabs, which is for lights and cameras. Now click on the cameras folder, select add camera. Figure 23, 21 show the property manager for camera. We went to camera, we've gone to camera type. It's very shows the menu. Notice that when you insert the camera, the Solidworks graphic window splits in two. The viewport, the left viewport, is the view of the camera, the model, and the model of their surroundings. The right view is the view through the camera. Using target selection box, aim the camera robot tower part. If you aim the camera, the moving part, the motion of the camera will seem unnatural unless the part is moving smoothly. For assembly, you might consider aiming the camera at a dummy part in the assembly so in a moving jerky fashion following the jowl. For example, they use it as a part with just a floating space, but generally moving left to right, up and down as you need it without being rigidly connected to any single part. Assembly. Test your camera spline. Select the spline in the first camera position selection box. If you're at T equals 0, the first key point, make sure the percent of position is set to 0 to get the camera to move around the spline. Move the time bar to position 0, 4 seconds. Edit the camera item motion manager. Right click inside light cameras when setting folder found only with the motion manager, not an assembly feature manager. And select properties option to move the percent and slider. Use the camera position to about 25%. Do this as many times as you need to go all the way around. If the parts in the model go out of the field of view, you'll feel the camera is too far away, too close to the model. You can move the camera, change the lens, move the camera, exit the camera, property manager, edit the 3D sketch. Now remember that when you're editing unconstrained 3D sketches, best to do it with the orthogonal views. Any point that you drag the plane move the plane on the screen, the best way is to edit the size of the spline is to view it from top view and drag out individual spline points. Going beyond 100% or 360 degrees. If you take the animation amount around about more than 360 degrees, you must work around to get it to work correctly. For example, if you have the percent slider go to 0, 25, 50, 75, 100, then 25% of the animation will reverse direction about 125. The way to make this happen is the animations maintains continually the place of keys about both 100 and 0, close enough to one another. The time difference is less than frame rate of the rate of the animation. Frame rate is set by the motion steady properties. Icon far right side of the motion manager toolbar. For finished animation, frame rate could be neighborhood of 30 frames per second, which means time for one frame would be 1/30th of a second, about 3/100th of a second. Therefore, 100% of it happens in 2 seconds. You could put it 0% at 2.01 seconds. Transition would never be seen. This workaround this workaround is used widely by people who know the software as well. Same sort of tactics work if you go beyond 360 degrees. You must use the zoom tools in the lower right corner of the motion manager to enable you to see what's going on. Figure 23, 22 show the two camera key points getting very close together in this point way. To change the percent position, double click the key point. Camera point manager will become available. Okay, they're right back to back, so you've now clicked on the key point and the orientation to show the second customs. Alright, the animation with key points sheet chapter briefly discuss the key points to introduce the idea. In this section, you learn how to use them in more detail. You can think of the key points as a snapshot, particular moment in time. If you say 4 second mark of the wheel must be 3 inches from the wall, This statement describes a key point position of the wheel to create a key point with any property. Drag the time bar over the new time and make a change with the property. Any of the animation properties listed earlier in the chapter can create a key point. Auto key button on the motion manager does with the moving components without what disable the view key creation does for animation view changes. When you have this button pressed, moving the parts with the cursor will create a new key point in the current location of the time bar. Getting started, consider the easy, useful example. A customer wants you to make a little animation of the holder stethoscope that will show the potential client on PowerPoint. The holder opens the stethoscope and slides out, and the animation reverses. On the website, the assembly animation saved as animation folder scope cozy solid assembly. The assembly is completed. Animation time shown figure 23. Animation used real view display. Customer has set it good enough for this purpose. Using it to produce the rendering time significantly compared to view using photo view 360 render animation. So the test scope animation setup. You first take the task to set up with the camera. You do this without. You could do this without a camera, but the cameras are a convenient way to store a particular view, along with settings, lens, angle, perspective, camera position, target. In addition, you decide the photo 360 later. The cameras are the only way to get the depth of the field. The additional realism and the other advantage of the camera is that you control the area of the view more closely. If you not use a camera, the area of view is just whatever is available on the viewport. Within a camera, you can specify a size, aspect ratio, available area, cropped appropriately. Both stethoscope mode and the cut piece enable the different parts of the B position. You must position the ports camera so the break between the head and the earpiece is not visible. Leave enough open areas so the stethoscope comes out and wouldn't run out of the area of the view. Note, when adjusting the position of the camera, it's often easier to adjust the actual view of the manipulating without a view than manipulating the camera. Camera property manager, deselecting lock camera position, except when editing option enables you to manipulate the view directly. This setting is selected by the default will display with the camera in a red X icon. If you try to rotate the view when the camera view is on, switch to camera view, deselect disable view key creation. Using time bar with key points, good idea to start animation some smooth stillness. Start the animation within the motion view. The viewer not have the time to adjust. The second is usually enough. Expand the top part file. Click the key point. Move row on the 0 time marker. Click drag 1 second mark. This means the top won't move between 0 and 1 second. Now move the time bar over 2 seconds. Open the top, dragging it slightly. It should open only about 1.5 inches. Now move the time bar's 5 second mark next to you. Purposely create a mistake so you can learn how to create it. The 5 second mark. Move stethoscope out over the holder 3 and 4 inches. Holder 3 and 4 inches to try to make sure that you don't have it far enough the rubber tires run into the plastic parts. Move the create change of the bar and show the position of the scope head part moving continually at about 0 to 5 hundredths of a second motion opposed to starting at 3 second part. You can see how to fix the mistake in figure 23-24. Clicking the key point of the motion scope head part with the control drag with a 0 second on the mark and the 3 second mark. Calculated with a setting. If you run the animation at this point, let's see the scope head. Make sure the unexpected movement. A yellow line will appear to the left, changing the bar for the part. To fix this, click the calculate button next to the play button. Copying it or mirroring motion, the animation essentially do that at this point, except for the stethoscope needs to go back into the holder to make it must close. You don't have to manually create all steps to close the device, although you could more efficiently simple copy to reverse the path that you have already made. To copy the both setting of the motion, top opening, head sliding out, drag micro A window around the key points, select all of them all, then click drag, and then 6 second mark. Notice that creates a situation shown in figure 23-25. If you play the animation at this point, it won't be what you want. It simply stacks the same motion on top of the original motion you want to be reversed. Copying a motion of the parts. With newly copied key points, you will be selected. Right-click one of them and select reverse path. Notice that they show the symmetrical key points. Or adjusting the speed of the actions. The animation is almost complete, but it would be better if the second half of the animation went faster than the first half. To do this, move the key points on the right side over the change of the bar forward to the left. You may want to move both key points for the top bar closing and start or closer at the time. When you scope, the head is back inside of the holder. You can even you could even make some of the motion overlap and top starts and closing before the scope head is fully inside. Again, if you see a strange effect such as the scope head not going all the way back into where it belongs, try calculating a button again. Calculate essentially rebuilds the animation after it changes. To make motion light a little smoother, right-click any of the empty space inside the timeline area. Choose Select All. Right-click one of the key points. Select Interpolation Model Mode. Click Ease and Out option. Click Calculate again to watch smoother animation. And that's the calculation up there in the left-hand corner. After strange effect, scope head not going on all the way back, try clicking calculate button again. Calculate essentially rebuilds the animation to changes. To make the motion a little smoother, right-click the empty space inside of the timeline area. Choose Select All, then right-click one of the key points, select Interpolation Model, click Ease and Out option, click Calculate again to watch the smoother animation. If you want a variable speed to see, say scope ahead and scope. Want the variable speed. Say the scope head coming out of the holder, for example, it starts coming out slower, then speeds up. You need to add at least one more key point to do this. Position of the time bar left out of the middle of the first scope head change bar of the click. Place key. This adds a key point with the existing change bar that's shown in figure 23-26. Move the key point to the right. Make sure the next new key point for the ease and out interpolation mode. Recalculate. Run the animation again. If you decide the entire animation is too fast or too slow, you can adjust this easily. Drag the rightmost key point onto the top row of the Alt with the Alt key to press. This will scale the entire animation up and down. Alright, over here shows the animation check save attributed button. Outputting the animation. After you're happy with the animation, save the animation toolbar button. This brings you to the Save the Animation File dialog box shown figure 23-27 option. Output file formats or AVI or BMP or TGA series of still images. You could be fine still images to make animated GIFs to use on the website. Other types of outputs such as Flash, QuickTime are not available directly on Solidworks software. Movie format converts are available only on web for this purpose. Movie format converters are available only on the web for this purpose. The option rendering are used simple SolidWorks screen photo view 360 example of real view SolidWorks screen rendering provides sufficient quality of the purpose of the main advantage of photo view 360 real view are that it offers better choice of backgrounds, anti-aliasing, and more shadow control. Alright, looking at other options, the image size aspect ratio are available only when you do not use a camera. Without the camera, you are at the mercy of size and shape of the SolidWorks graphics window until you have the animation to file. Save the animation to a file. Schedule button enables you to schedule the output with a more convenient time. You can normally use the option using a photo 360 because of the rendering. Animations can take many hours to complete, depending on the rendering settings, length of animation, and the number of frames per second. Figure 23-27, saving output data of the animation. We've now picked this file name in a folder for the animation file, and save type is AVI, solid rendering, work screen, image size, aspect ratio, fixed aspect ratio, use camera, aspect ratio, custom aspect ratio, frame information, frames per second, frames to enter animation time range, motion, blur, length, offset, save, schedule, and cancel, and help. Frame information enables you to set the quality of the finished rendering. Low frame rates result in choppy motion. High frame rates are much smoother, but files may become unmanageably large. High quality animations generally fall between 25 to 30 frames per range. Running test animation. Depending on the length of the animation, other setting test animation might run about 10 frames per second. You must also consider using specific range at a time to test just a part of animation. Unfortunately, many of the decisions you make regarding animation quality settings directly relate to the time you have produced the movie file. The biggest time saver is to avoid a photo view 360 and real view suit your needs. You're well ahead on time. Alright, selecting a compressor. When you save an animation, the software prompts you to select a video compressor or codec, typically option Microsoft Video Cinematic Compressor. Sometimes when you record playback a movie with a particular compressor, you end up with lots of video noise in the movie, and that happens. Another compressor, for example, if the Microsoft Video for an animation has a lot of video noise, you can switch to Cinepack, see the results are better. Animation with basic motion. Basic motion functionality, formerly known as physical simulation, involves setting of the motors to turn parts and gravity to move parts and springs and collision to create animations that cannot be driven by mates or free motion. You differ solve the rest of the animations in this chapter. Alright, basic motion does not take into account effects such as momentum, bounce, resistant friction, velocity, and reaction forces. To analyze the effects, you need to use motion analysis. Study type selection boxes appear in the upper left-hand quotient motion manager. You need to use basic motion for the figure 23.2 for this example. Using gravity and contact. Figure 23.28 shows assemblies of the demonstrated gravity, contact functions, basic motion. Problem is easy to set up. The part is easy to move the ball and underfine using one mate to keep it in plane as it moves zigzag parts and fixed concentration. Alright, on the web, the assembly labeled zigzag solid assembly. Setting up a contact and gravity. When you've added physical simulation item to the motion manager design tree, looks like a figure 23.29. Editing items such as contact, gravity do not use the interface option and have been available with the rest of the Solidworks software. Click select. Doesn't bring up the context toolbar. You have to right click and access the full right menu, mouse button menu. Because the example goes so quickly, you may want to use a playback speed drop down, may get a better look at it. You can also select the playback looping option, which drops down menu right back to the playback speed. For contact to be successful, the two parts will not go through each other. It might be necessary to increase the frame per second animation basic motion. Also, you may have to increase the geometry accuracy of 3D contact resolution setting. Remember that SolidWorks calculates contact at each frame, steps of the movement of the interference. So if the part moves fast but the frames are few, the part may have already gone through a second part with the NO contact registered. The motion manager design tree with added items. Using motors and springs. Using motors does not necessarily require basic motion, but it includes springs and or contact gravity problems. It does. Torsion springs require motion analysis, and both linear springs require only basic motion. This example available with the download materials and animation folder. Ratchet solid assembly showing the motor driven the gear with a ratchet held in the gear teeth by a spring. As shown in figure 23.30, a swinging ball on the spring is added to show the instant simple 2D functionality. Alright, a motor gear ratchet assembly driven by basic motion. To set this example, we'll apply the counterclockwise motor to the inside of the circular, apply counterclockwise motor to the inside circular edge of the gear. Select the block and reference part of the example to start with the motor in slow RPM revolutions per minute. Move the time bar out of a few seconds to assign faster speed, so that the motor speeds up over the time. So now we're looking at rotary motor out of the SolidWorks ratchet. So this little drawing with the arrow right here, that's your rotary motor, linear spring, 3D contact, linear spring, gravity are the ones we're using on SolidWorks Lite. Linear spring is easy to apply. Set the location on both ends. This example has circular bosses and block on ratchet hold and spring. Animation chain and spring using motors. Two of the most common requests of the people learn how to make animation SolidWorks are animating chains and springs. Simple animation. You have a couple of tools you should know about. Early in this chapter, the yoke link assembly was used to demonstrate how to flex and strap. You have the context relations and loft. Chain gearing and spring example. You have the motors to drive a train. Drive gears and flexes a spring. The spring is modeled element, not a part of basic motion. The driving element is the motor. Figure 23-31 shows the assembly ready for animation. Opening an assembly called Chain Assembly Pattern Solid Assembly for the material of Chapter 2 of the download site. The assembly consists of the following components: 2D assembly sketches, 1 assembly plane, 1 assembly access. Two-part chain pattern making up the chain. Two gears, one spearing model in context connects the ending of the chain to the plane. Chain is achieved with the inner and outer links of the chain pattern. The spring is achieved with an inner context relation. Animation is driven in a singular linear motor. The model is created with the first drawing sketch of the representative path of the chain. This consists of lines and tangent arcs next in order to the path. A single smooth continuous. Any second sketch is created. Fit spline is used to lay as a spline over the lines and arcs. Very small tolerance value is used with the curvature of comb and using the spline looks like a close to a linear arc combination as possible. We see the mate lightning bolt interface of the creating of the chain pattern walks through the selecting depending on what type of chains you are using will even locate the links of the path for you. Without the chain pattern would be required nearly 100 mates to make a functional chain with the chain pattern property manager as shown in figure 2332. Once again, go to the chain pattern to make a better chain using a chain pattern to assemble along a chain along a path. The gears are positioned at the center of the arcs on sketch 1. The tricky part of the gears is involved with the rack and pinion match to linear motion and the link chain, the rotation motion gear, because this is just an animation, not real analysis. Idealizing the assembly that won't have any adverse effects. Construction of the spring simply using straight line arrow or in context connector between the last link of the chain plane of one assembly line is used with the path. Sweep path of the twist enable the reasonable approximation of the spring for animation. It doesn't flex with the dynamic assembly motion, but it does for animation. All that remains in this is the motor. Figure 2333 shows how the motor is driven in linear motor with the oscillation mode. Displacement versus time chart shows how much of the chain moves during a 6-second animation. You can also see the chart shows how much the spring extends and retracts. Charting the motion assembly. Display versus time. Component direction motor. Component direction face is direction motor. Part oscillation dimension, oscillation in hertz, in degrees. Click graph to enlarge, more options. Although this assembly animations are simple to demonstrate, many of the techniques you need to make an animation more complex. Modes with controllable output are a big part of animation. Automatic machinery making parts appear flexible, adds greatly realism to any animation. Alright, the robotic arm on the left, using mate controller. Mate controller is an interface that helps you drive the position of the parts that is through selected. You may use this configuration, but configurations are not required to use it when using motors. Best work to under defined assemblies by the mate controller works best fully defined assemblies. You drive the mates using values, a slider, or by visually dragging parts on the screen. The tool would help recommend you if you have a lot of mates, a lot of possible degrees of freedom, multiple moving points that may react well to manual dragging, such as an arm or shoulder joint, elbow joint, wrist joint, fingers. Interfacing enables you to lock down certain mates to control what the motion happens, even when you are visually dragging parts on the screen. This is kind of the thing you want to do manually, suppressing, unsuppressing mates to enable the restricted movement. Rather than using configuration to remember the position of the assembly, mate controller allows you to specifically remember position, specific value with multiple mates. This is much simpler than using configurations when you're done. You can save all this information out of configurations if you want to reuse the position data for the drawings, rendering animations, or other purposes. It may be a good idea to build your assembly slightly different when you plan to use a mate controller. Instead of using concentric mate for the joint, you may want to consider using a limited mate for the angles. Using actual values number gives more positive control. And as usual, best practice name of the mates to use the mate controller in order to provide some clues about the functions of the mates, such as rotate baits. If you get them in order, the mate controller interface will set up logically to help you control the motion of the assembly in a certain order. You can initiate mate controller in one of several ways. Use the mate controller icon in the assembly toolbar. It may not be there by default, but use customized interface to put it in there. Use the insert menu if you have selected one or more mates. The supported types of from an assembly feature manager, you can access the mate controller through the right menu mouse button menu. Supported mates are listed later in this section. Once you've used a mate controller saved at least one position, there will be an entry for the mate controller at the bottom of the assembly feature manager. The positions created by the mate controller can be renamed, reordered to create an animation mate controller property. It has an animation interface at the bottom as shown in figure 2334. So 23 shows the mate controller, shows the angle, the dynamic mates, and which ones they are. Rotation, redo, save, close, right, lock, unlock, position, display tree, rotate base, angle, orange arm, angle, gray arm, angle, open arm. So it shows all the mate positions that were listed in the mate box and animation position, and then it shows all select, calculate, play, stop, next, back and forth, loop, and then save animation. Alright, the button shows the left enables you to collect all the supported mates, and in the assembly, supported mates listed as follows: angle, limited distance, path mate, control the distance along path, percentage along parameters, slot mate controls distance along slot, percent along slot parameters, width mate, dimension, and percent. If you want to create multiple animation motion schemes, you can also create multiple mate controller features in this assembly. Alright, the bottom line, if you keep your animation relatively simple, the Motion Manager tools, the Solidworks standard, should produce adequate results for some situations. If you're using mate to drive a motion, to be sure to follow the best practice recommendations for the mates. If you're manually positioned parts, remember to place the key points close together if the motion curvature changes abruptly. If you make large animations end product, use the AVI file acceptable to do this break animation with a smaller bit that makes each of the part animation but simpler to do. We're going to even have delegated the other uses of the other machine parallel processing. It may also be beneficial to post processing to add caption narration to your movies. A few words explanation might be valuable to viewers. Master, and in a blank assembly, create a camera with a circular path that focuses the origin. Assembly with a template, then template to create an assembly turntable animation, and assembly with the part you put in the assembly. Using the large dump truck, make an animation bucket, raising and lowering with a second before motion, second between raising and lowering, and a second after lowering it. Try to use the tools for mirroring in the path that learned in this chapter. Use real view setting hardware is capable. Save out as an AVI movie or previous animation. Make sure it plays back. You expect on your computer at least one other computer. Part 4: Creating drawings.